All right. Good morning, everybody. It's so good to be back and see you all again. If you can all hear me, please say yes in the chat box. All right, perfect. Let's get into it. All right, so just to remind you all who I am, if you're tuning in for the first time, I am Karabo Hashani and I'm doing natural science grade 6 with you. And you can follow me on Facebook at Karabo Fiona Hashani. All righty. Right, so now what is happening today? At the end of the lesson, sorry. All right, you will define solutions. So if you remember correctly, yesterday I did say that we're going to be talking about special solutions. So today we'll be defining solutions. We will know when a mixture is a solution. We will know the differences between a solute and a solvent. All right, so let's just do a quick recap. Yesterday we spoke about mixtures, all right? Now, who actually tried yesterday's activity and mixed the sand and the sugar? Please raise up your hand and you can actually unmute yourself, or I'll ask my host Melanie to assist me to unmute you, and then you can actually tell us how did that experiment go for you. All right. Let's have Lizelle. Lizelle, how about you tell us how did that experiment go yesterday? Lizelle, are you here?
She has been unmuted, but she's not responding.
All right then. Anybody else want to try? Who can just remind me what we did yesterday and who actually tried yesterday's activity? All right, always he said that, all right, he didn't have any sand. Oh, I understand. All right, cool. Awesome. So then let's just move right along. But I'm glad that maybe some of you did actually try. You just had to mix some sand and some sugar together and try and separate the substances. All right, so let's just move on to today's topic. All right, so we are moving to solutions. Now, what exactly are solutions? Solutions are also mixtures. Now, remember, they've also been mixed together to make a solution. Some solutions can be made by mixing a solid and a liquid together, such as sugar and water, salt and water. So eventually, when it dissolves, it would then make a solution. Solutions are uniform in appearance and the solid cannot be seen after mixing. Now let's look at some of those pictures at the bottom. Listerine, a mouthwash. A lot of materials and a lot of substances have been mixed inside that Listerine to make it the way it is. But we cannot exactly see what solutions have been in there. We cannot see what particles have been mixed in there to make it the way it is, all right? Right, when is a mixture also a solution? So we need to find out now, when is it actually that a mixture can also be a solution? When two substances are mixed, it will be possible to still see each substance in the mixture. Is sugar and sand a mixture? Yes, it is a mixture because while we can still visibly see the substances inside the container, we can still see the sugar and we can still see the sand. And we can obviously separate them by sieving. It would be hard to separate them by hand sorting. So of course, sugar and sand is a mixture. A solution, however, is a special type of mixture. Right, so what makes a solution so special? You can tell me what makes a solution so special. For example, a Listerine mouthwash. Why is it so special? You can give it a shot. What makes a solution so special? Remember just to type in your chat box. What makes a solution special? Anybody give it a shot? I see some of you thinking. What makes it so special? All right, I guess nobody wants to answer this time. Right, let's find out. Okay. Now, when And also, when is a mixture also a solution? So now the reason why a solution is so special, someone said the type of mixture, Charmaine said it is a liquid. All right, and Wenzile said that you can't see the particles in it. That is 100% correct. It makes it special because you cannot see what has been mixed inside of it. All right. And Kira also goes on to say, tone of the solid is not visible. That is 100% correct. And obviously, when is a mixture also a solution when different particles have also been mixed inside? All right. Often, the best way to answer a question is to ask in a different way. When is a mixture not a solution? So how is it that jelly beans are not a solution? Why would we say jelly beans are not a solution? Why are jelly beans not a solution? Type in a chat box. Why are jelly beans not a solution? Anybody got an answer? All right, Kira says you can still see all of the jelly beans. Correct. Charmaine, it is a solid. All right, almost jelly beans you can consider them a solid. Correct. Already said because it is not a liquid. All right, excellent. Lelam said because they are visible. 100% correct. So obviously now we know a mixture is not a solution because it is visible. Jelly beans are not solutions because they're not actually mixed together and disappeared in one. All right, we can still see the green, the yellow, and the black jelly beans. Excellent, guys. Awesome. All righty. Now, so what exactly is a solution? What exactly is a solution? So when two substances make a solution, it will look as if one substance has disappeared into another. Have any of you actually made oros juice, like the normal? Who loves oros? I do. I love oros, right? I see papers knocking there, nodding, awesome. All right. Now, if you take some oros juice and obviously mix it in some water, you'll realize that it seems as though the water has supposedly disappeared because now the juice is actually now orange. It's no longer clear as before. All right. So it seems as though the water has disappeared inside the aura. All right, just like that picture there at the bottom, we've just added a bit of orange juice and 3 cans of water, but now the water seems to have disappeared inside the orange juice because it has now been a different color. All right. The substance that looks as if it has disappeared is called the solute. You need to remember that for the quiz at the end. So the substance that has disappeared is called the solute. In this case, the water seems to have disappeared. We would call it a solute. All right. The substance that we can still see is called the solvent. We can still see that the liquid has turned orange from the aura, meaning that that is a solvent. We can still see the aura. So now remember, the one that has disappeared is the solute. The one that we can still see is called the solvent. Awesome. The solvent and the solute together are called the solution. Now, when I mix oros and water together, I have made a solution. All right, remember, the water has disappeared. That is a solute. I can still see the orange juice. That is a solvent. Together, they make a solution. Are you all with me? All righty. Now, is sugar and sand then a solution? Would sugar and sand be a solution? Would sugar and sand be a solution? Abo says no. Right, Abo, please unmute and tell me why. Why is sugar and sand not a solution?
Because can't you still see one of the two? Like, can't you still see the sugar and sand?
Ah, beautiful answer. Thank you, Abo. 100% correct. Because you can still see the sugar and the sand. Thank you so much for your answer, Abo. Very, very good. All right, next slide. Soluble substances. Now we're going to discuss the differences between soluble and insoluble substances. All right, now what exactly are soluble substances? Soluble solids, which are solutes, can dissolve in water. All right, anything that dissolves inside water would be a soluble solid. All right, anything that dissolves inside the water. The substances in solutions cannot be separated by sieving, filtering, hand sorting, settling, and decanting. We spoke about all these terms in yesterday's lesson, so you should be familiar with the terms. So with a solution, it is very, very hard and almost impossible to separate them by sieving, filtering, or any of the other methods of separation. Some solutes can be recovered, which separated, by evaporating the solvent, such as recovering salt from seawater. Now, if you actually want to separate a solution, you would need to go through something called evaporation by putting the liquid in the sun and ensuring that the water evaporates, leaving all the sand or salt particles at the bottom. Right. We'll do an example later just to give you a better understanding. But evaporation would be a way to actually separate or to recover the solvent from the solute. All right. When substances dissolve, solute particles become dispersed in the spaces between the solvent particles. Now, the moment they get separated, we can then see that the water has evaporated and all the smaller particles, that could be either the salt or the sugar, has left to be at the bottom. All right. We have a word for substances that form solutions when they are mixed with water. These substances are called soluble substances. So all the substances that have been mixed with water are called soluble substances. Substances that do not form solutions when they are mixed with water are called insoluble substances. So if something is not mixed with water, it is called insoluble. If it is mixed with water, it is called soluble. And lastly, some solids will not form a solution in water, right? Which then makes it an insoluble solid. Excellent. Let's move on. All right, now here's just a little example of what exactly do we mean by a soluble. Now, when a substance mixes with water, it forms a solution. Anything mixing with water is considered to be a solution. The substance is soluble, all right, because it has mixed with water. This means that it was able to join with all the other water particles. Now, if you look at the very first picture, that picture there are just all the water particles. They look like little teddy bears with ears. Those are water particles. Then the picture in the middle are your sugar particles. Now, for me to make a solution, I need to mix the water and the sugar to make a sugar and water solution. All right. Now, the last picture actually shows how the sugar and the water solution have actually joined. All right. Now, remember the little teddy bear ears, that would be the water particle, and the little shape there, I think that would be that's 5. Hexagon, that would be sugar particles. Together, that would make a sugar and water solution. All right. Now, when a substance mixes with water and does not form a solution and only forms a mixture, the substance is insoluble. All right. So if it forms a mixture, it is then called an insoluble. This means that the particles of the substance are not able to join with water particles. Right, remember that. Right, next slide. Alrighty. When a substance mixes with water and does not form a solution and only forms a mixture, the substance is insoluble. This means that the particles of the substance are not able to join with the other water particles. It is very hard to mix oil and water together. The oil particle stays at the top and the water particles stay at the bottom. It is very, very hard to mix oil and water together. Right, now let's talk about saturated solutions. Now I want you to imagine making a nice warm cup of tea and you add 3 teaspoons of sugar. Now imagine you add another 5 teaspoons of sugar. If you were to drink this tea, what would you notice? In your chat, please tell me, what would you notice? You've already added 3 teaspoons of sugar and now you're adding another 5 teaspoons. Yes, lovely, that is very, very unhealthy. Excellent. But what would you notice? Right, Teresa thought that it would be sweet. Yes, very, very sweet. Anything else? Right, as well, or let's see, right, it would be sweet. Anything else? If you were to drink this tea, what would you notice? Hanmo says diabetes, which actually links to the other lesson that we had about food, nutrients in food. Marola says the sugar would have dissolved. Taylor says the sugar would not dissolve. All right. Now, depending on how much you actually add into the water, it might not actually dissolve. All right. Lelang said it would be sweet and I would not even be able to finish it. All right. Stephanie, not all the sugar would have dissolved. Excellent. So now not all the sugar would have actually been able to dissolve. A solution is saturated when no more solute can dissolve in a given amount of solvent. Now, if you mix all of this, the sugar with the water and too much sugar inside the water, it will not be able to dissolve. This would then mean it is saturated. This would then be a saturated solution. All right. A very good example would be making a sugar crystal. Have any of you actually made the sugar crystal before? Has anybody made? There we go. Lizelle actually said maybe it'll make a sugar crystal. Excellent, Lizelle. Thank you. And Olesi says no. All right, we're actually going to try make a sugar crystal sometime during the lesson. Maybe not this lesson, but sometime. All right. All right, I want you to think of now crystals in nature, right? Now that we actually spoke about crystals, which actually means crystals are saturated, all right? So an example of crystals in nature. Have you ever visited a cave? Has any of you actually went to visit a cave? Anybody? All right, Olesi says yes. Some of you say no, no, no. All right, cool. Right, now inside, you may have seen crystal formations called stalactites and stalagmites, all right? Now, stalactites and stalagmites form inside limestone caves. Stalactites hang down like icicles and stalagmites grow from the floor of the cave upwards. All right, someone said Sterkfontein caves, you're 100% correct, right? Now, stalactites and stalagmites always occur in pairs. Caves form when water slowly dissolves and the limestone underground. The dissolved limestone can crystallize again when the water evaporates. This is also a slow process and it happens when water drips down from the ceiling of the cave over a long period of time. The water drops that land on the floor of the cave evaporate over time, and where they fall on the same spot repeatedly, a stalagmite eventually forms. So over many thousands of years, the stalactite and the stalagmite may connect to become a column. Now we know exactly how stalagmites and stalactites form. by obviously dripping in the same place over a certain amount of time. All right. That's just something extra for you just to be aware of. Right, so now we're going to do a little activity. All right, so you need to just stay awake. All right, now this is just going to be a very, very fun activity. Just like we had yesterday where you had to actually go outside and do something. This one is also very, very similar. All right. Now, the aim of this activity, though, is to separate the solution by evaporation. Now, listen very carefully. What you're going to need is half a glass of water, 3 tablespoons of sugar, a spoon, and a dish. Now, this will obviously be done in your own time just to actually see how to separate the solution by evaporation. Now, if you remember correctly, we said that we cannot separate solutions. If I ask you to separate the dishwashing liquid that mom used to wash her dishes, it's going to be very, very hard. So we are actually going to try and separate sugar from water when it has already been mixed. All right. So what do we need to do? We need to mix the sugar and the water, pour some of the mixture onto a dish, and leave the dish in a warm, sunny place for a few days. So you just need to ask mom to borrow some sugar and a glass, all right? And you're going to pour the sugar with the water, mix it in a glass, and just leave it out in the sun for a couple of days, all right? And you need to tell me, what do you see? What do some of you think you will see in your chat? Now imagine you've just done this mixture, sugar and water mixed together. You put it in a warm, sunny place for a couple of days. What do you think you will see? Just type in your chat and let me know, what would you see? Aiden says water, Lizelle says sugar crystals, Stephanie crystallization. All right, very, very good. You would actually see the sugar crystals. Already would be a solid. Lutando says water. All right, so now if you leave it for long enough in the sun, you'll actually end up seeing sugar crystals left at the bottom of the bowl or the glass. The water would have then evaporated. All right. Now the next activity, we're going to discover how sugar can actually dissolve in water. All right. So we're actually going to do this activity now. Now I'm going to stop sharing the screen and I'm going to show you some of the stuff. And what we're actually going to be doing is testing saturated solutions. So what do you need to do? You need to find out how much solute will dissolve in a solvent. You need to find out how much solute will dissolve in a solvent. We're going to need a glass or a beaker, half a cup of water, and 1 cup of sugar, and 2 teaspoons. All right, the method, we will need to pour water into the glass, add 1 teaspoon of sugar at a time, stirring well each time until the sugar no longer dissolves. Right, so I'm going to stop sharing the screen and you're going to just have a look at what I have for you. Okay, so over here, I've got half a glass of water. I've got a teaspoon. And I've got some sugar, all right? Now you need to count and keep track as to how many teaspoons of sugar am I going to be adding inside this glass of water. Because I'm going to eventually lose count, all right? I'm going to start.
Apple.
All right, that's 1. Now I'm going to mix until all the sugar dissolves. Going to keep mixing. It is brown sugar, which is a bit thicker than white sugar, so it does take a while to dissolve. All right, there you go, slowly dissolving. Okay, all done. I'm going to add some more. So I'm going to add until no more can dissolve anymore. That would mean it's saturated. The water slowly starting to turn brown. All right, it's all gone. I'm going to try it now. Now keep up. Remember how many I've been adding. I've lost count already. There's still some sugar pieces at the bottom. Okay, it's gone. Gonna add some more. Let me actually add another one. Remember, I hope you're counting, okay? I'm not. Okay, there's some at the bottom. There's still a whole lot at the bottom which doesn't seem to want to dissolve. Okay, it's actually all gone. I'm going to add two more. I'll make it three more. I hope you guys are counting. I really love to count. Remember, it's brown sugar. That's why it's getting this color. And brown sugar particles are actually a lot thicker than white sugar. Okay, now there's a whole lot of sugar at the bottom. It's going to be a bit hard for you to see, but there's a whole lot of sugar at the bottom that doesn't seem to want to dissolve. Now, how many teaspoons of sugar did I add in here? How many teaspoons of sugar did I add? 8. Geez, okay, that was a lot. All right, now if I had to drink this would obviously be extremely sweet. Right? Now, I'm not going to take this to waste. I won't pour it out. I'll actually try and make a sugar crystal. So during the time, I'll actually show you what my sugar crystal will look like. All right. Okay, let's carry on. All right, so the result, how many teaspoons of sugar did you add until the sugar no longer dissolved? I added 8. All right, there were 8 teaspoons of sugar, but now when I look, it's actually all gone again. So I'm actually going to keep adding while I'm teaching, and actually going to eventually see maybe a whole lot of sugar stuck at the bottom. All right, maybe you can actually try that at home and actually find out how many teaspoons of sugar would you need to add until it actually dissolves. I wouldn't drink this, obviously extremely sweet, but I will try and make a sugar crystal. Actually, now it is completely clear. All the sugar is gone. There's nothing in it. So this is not saturated thing. The fact that I still can't see the sugar crystals means that this is just not saturated. It is a solution, but it's not a saturated solution. It would be saturated if there were still some sugar particles at the bottom. I think I just pour a whole lot. So if I maybe just pour a whole lot of sugar and mix, maybe only then, see all of that? Maybe only then it would be saturated, right? But I'll continue mixing. Alrighty, let's move on. All right. So So we did this activity as well yesterday, but now I want you to actually tell me the different, sorry guys, my battery seems to be fine. Sorry guys, I apologize for that. My battery was not charged. All right. Now I want you to look at this table. The first one is sugar and water. After stirring, would sugar and water be a mixture or a solution? Right. Would sugar and water be a mixture or would it be a solution? It would definitely obviously be a solution. All right. It would be a solution. Salt and water, it would also be a solution. All right. What about sand and water? Do you think sand can dissolve in water? Would sand and water be a solution? Yes or no? All right, sand and water would obviously be a mixture. So no, of course, it would not be a solution. What about oil and water? Oil and water? Nope, that is not a solution. What about vinegar and water? All right, no, vinegar and water, that would be a solution. The vinegar would actually dissolve inside the water. What about copper sulfate and water? Copper sulfate is just a blue substance. Do you think copper sulfate would be able to dissolve in the water? Right, Teresa said yes. All right. So, of course, copper sulfate and water is a solution. All right. All right, now takeaway message. Now, there are many kinds of solutions, but the most well-known ones are mixtures of a solid and a liquid, such as sugar and salt. All right. Next one, not all substances dissolve in water. Those that dissolve are called soluble substances. Those that do not dissolve are called insoluble substances. All right. Solutions cannot be separated. All right, I hear someone's asking what is copper sulfate. Now it's actually just an inorganic salt, all right, that can be mixed with water. It's actually blue in color. So when you mix copper sulfate and water, it's blue. All right. So basically, it just helps to bind matter together. That is what copper sulfate is. All right. Hope you all got that. A blue substance, an inorganic salt. All right. Solutions cannot be separated by sieving, filtering, hand sorting, or settling and decanting. This is because solute particles are dispersed between the solvent particles. Also, what I would like you to be aware of is that solutions can be separated by heating so that the solvent evaporates. The dry solute will be left behind when we have dissolved so much solute in the solvent that no more solute can possibly dissolve. We say that the solution should be saturated. Right, just like this over here, all that sugar I added is gone. So this would still mean it's not saturated. All right. These are some helpful links that I would like to help you with. You can find some saturated solutions on YouTube. And next week, we're going to talk about dissolving. All right. Please stay tuned in for that. Remember to follow us on Africa Team Geeks, hashtag Lockdown eSchool and at DBESA. Thank you so much all for tuning in and being such an amazing class today, being well behaved again. Thank you, and I'll see you again next time. Have a good day. Goodbye.